Let's look at the right-hand sum again, this time on a general interval AB, but again for equally spaced subintervals. This is the formula for the right-hand sum. It's a little bit more generic. Delta x is going to be the width of each subinterval. F of xi will be the function value at the right-hand endpoint, which is given by this formula. Let's see how this works using an example. Let's take the example with f of x equals minus x squared over 25, where the interval is the interval from 1 to 5, and let's use n equals 8 in this example. The easiest thing here to compute is delta x, so let's start with that. Delta x is just going to be the difference, 5 minus 1 divided by n, which is 8, and so we get back a half. Xi, all we have to do is take a, which is 1, and add on I times delta x, which we computed to be a half. So if we take this picture here, this is our picture of minus x squared over 25 with 8 subintervals. The xi's that we're going to use are going to be 1 plus I times a half. Again, a is 1, delta x is a half. We just put 1 and a half into this equation. These xi's lay out along this as the right-hand endpoints. First of all, x0 is just 1. That's actually not used in the sum, but we'll put it down. Then x1 will be the first right-hand endpoint we use, 1 plus a half. That's when I is equal to 1, so we put I equal 1 in here. 1 plus a half is this point right here, so we're going to use f of x1. And then we do 1 plus 2 times a half is 1 plus 2 over 2, which is actually equal to 2. So that'll be the right-hand endpoint for this. Then x3, when we put in I equals 3, that'll be the right-hand endpoint for this box. And then I equals 4 will be the right-hand endpoint for this box. And so on. We get x5, x6, x7, and x8. In each case, we got these numbers by putting in this number, say 5, into this expression. Here we put in 8. X plus 8 over 2 is x plus, or is 1 plus 8 over 2 is 1 plus 4, which is 5. So this is a picture of the boxes that we're going to use. And now we just need to calculate this sum. So we look at this sum. This delta xi is actually this delta x. They're the same for all I. So the delta xi is the same as the delta x. So let's put in delta x, which is a half, and this formula for xi, which is 1 plus I over 2. And so that redoes this sum. If we put in n equals 8, xi is 1 plus I over 2, delta xi is all these delta x's, which is a half, and is equal to 8. And now we can take this function, which is minus x squared over 25, substitute 1 plus I over 2 in for x, and we get minus 1 plus I over 2 squared over 25 times I over 2. This sum represents the right-hand sum for this function. In each case, we took the width of the subinterval, in this case a half, it was a half in all cases, and we multiplied by the function value, which was a negative number, which corresponds to minus this height right here on the first one, and then minus this height right here on the second one, and so on as we go along. And so when we write that sum out, our first term is minus 1 plus a half squared over 50. That's negative the area of this box. And then we get minus 1 plus 2 over 2 squared over 50. Again, this is the x2. That's this height, what we're computing right here, where it's negative the area of this box. They were always negative because this is below the axis. And then we get minus this one, and so on. I left out all the intermediate ones for space. I left out these through here, but then we pick up this one and this one. Again, they're minus because it's below the axis. Otherwise, we're multiplying the width times the height and putting a minus sign in front because the function's negative. This is just one big fraction. We can compute it. We get minus 19 over 18. That's minus the sum of the areas of these boxes. And we use a minus sign again because we're below the axis. That's the right-hand sum for general intervals.